Nuclear equations show radioactive decay. When working through these equations, you must remember that the mass must be the same on each side. We will first work through alpha equations. This is the symbol for alpha particles. Remember, it is a helium nuclei that contains 2 protons and 2 neutrons. This is the proton number and therefore shows it has 2 protons. And this is the mass number. So it shows it has 2 neutrons. If an element goes through alpha decay, it will lose 2 protons and 2 neutrons. This means it will lose a mass of 4 and a proton number of 2. Let's go through a worked example. Write the nuclear equation for oxygen going through alpha decay. Step 1. We know that alpha decay is 2 protons and 2 electrons, so we can write this in. Step 2. We need to find the new element this has now become. Oxygen has lost a mass of 4, so we can do 16 minus 4 to find the new mass. This equals 12. The new mass is 12. Step 3. Find the new proton number. It has lost 2 protons. We can do 8, which we've taken from here, minus the 2 from the alpha to make 6. Look on the periodic table for the element that has 6 protons, as that was here. This is carbon, so the new element will be carbon. We'll do one more. Thorium 234 going through alpha decay. So again, in step 1, we know that alpha decay is 2 protons and 2 neutrons, so we can write this above. Step 2, we need to find the new element this has now become. Thorium has lost 4 mass, so we can do the 234 minus the 4 to find the new mass, so it's 230. So we can write that in. Step 4, find the new proton number. It has lost 2 electrons, so we take the 90, take it away from the 2 to get 88. So we write that in. And step 4, we need to look on the periodic table for the element that has 88 protons, so the new element that it has become. This will be radon. Again, double check the answer. Does it have the same total of mass and proton number on each side? We will now look at beta radiation. Here is the symbol for beta particles. Remember, it is just an electron. So they have a mass of 0 and a charge of -1. The proton number is -1 and the mass number is 0. When an element goes through beta decay, a neutron in the nucleus turns into a proton. This causes the charge to go up by 1. Let's go through a worked example to explain that. Thorium going through beta decay. So step 1, this time we're doing beta and we know that it is an electron, so we can write in this into the equation. Because splitting an electron has no mass, the element has not lost any mass. So we'll do 234 minus 0 and it will still be 234. So we can write that in. Then we've got to find the new proton number. Remember, in beta decay, a neutron turns into a proton. So it gains a +1 charge. So we do 90 plus 1 and it will equal 91. Then we need to look on the periodic table for the element, the new element that has 91 protons. It's protactinium. Then we need to double check the answer. Does it have the same total mass on each side and the same proton number on each side? Yes, it does. Therefore, we must be correct. We will now look at gamma radiation. Gamma radiation is an electromagnetic wave and has no mass or no charge. Here is the symbol for gamma radiation. Here, remember, is the proton number. So 0 protons because it's a wave. And here is the mass number. 0 mass because it's a wave. This makes these nuclear equations very easy as there is no change. Let's do a worked example anyway. Thorium going through gamma decay. Again, we'll draw out thorium. We know that gamma decay is a wave, so we can write this here. Because spitting a gamma ray has no mass, the element has not lost any mass. So 234 minus 0 would still be 234. Again, to find a proton number, it's not lost any protons, so it'd be 90 minus 0, which is still 90. It is the same element because it's not changed in its proton number. So we write that. Double check the answer, make sure it's not changed, and there it is. Easy. You have now learnt about nuclear equations. You will find a summary of this information below. Make sure you test yourself using the quiz on reviseitright.com. Why are we the best revision website out there? Well, because we have it all in one place. Revision notes, summary videos, longer, more detailed videos for topics you're struggling on, exam question walkthrough videos where qualified teachers take you through the perfect answers to exam questions, worksheets, quizzes, computer marked exam questions, interactive flashcards, forums, the ability to keep track on where you are using our tick list, and so much more. But that's not all. We run at least 3 live lessons a week, and closer to exam time, this will be more, where you can tune into a qualified teacher teaching lots of different topics each week. The lessons will be interactive, and we go through exam questions and quick quizzes to ensure understanding as you go. We also run drop-in sessions where you can drop in, ask a tutor anything live, get the answer that you need, and leave. These are included in our silver and gold membership. This means that for an extra £10 a month, you can access at least 12 hours of lessons a month. That's under £1 an hour, which is incredibly cheap. Still not convinced? Try us completely free for 7 days and cancel anytime, completely free of charge. We offer this because we're convinced that you'll love us. So try us now.